wanna write this down. I wanna tell you how I feel right now. I don't wanna take no time to write this down. I wanna tell you how I feel right now. Hey.
Here we go. Life is a blast when you know what you're doing. Best to know what you're doing for your life get ruined.
Eh, ba't ang pet-pet mo? Same na lang ang pala na puso sa mga. Hindi ko alam.
Bakit dapat may taong matataba? Oopsie! Well, ito ay dahil nasosobrahan nila ang kailangan nilang energy kontra sa basal energy requirement na kailangan ng katawan nila. At dahil dito, nasastore ang mga sobrang energy bilang protein, glycogen, at fats.
So ano nga ba ang basal energy requirement? Ang basal energy requirement ay ang minimum amount of energy na kailangan ng katawan para mag-sustain or para mag-operate during rest or activity.
Yeah!
Baby boy, how do you lose weight?
I don't know. Ask me.
Well, either lessening your energy intake, which is your diet, or lessening your energy requirement, which is exercise. See, it's that easy. Now let's play some billiards.
You want my shoes? You want my shirt? My shoes too, nigga? Well, you need to go and get you some, go get you some. Go get you some, go get you some. Go get you some, go get you some.
Leo, what's metabolism?
Metabolism?
Let's check the book!
Wow, it's amazing. Yeah. Can I touch it?
No, you can touch me.
You can't touch the book. The book touches itself. Okay. Oh, please, magical book. Please tell us your ways about energy and metabolism.
Almighty book, what's metabolism?
Metabolism is a sum of all chemical reactions that takes place in the organism.
Oh. What are the two types of metabolic processes?
There are two types of metabolic processes called catabolism and anabolism. Catabolism is a breakdown of large molecules into smaller ones. Energy is generally released during catabolism. Anabolism is a synthesis of large molecules into smaller ones. Energy is generally absorbed during anabolism.
Oh. What's the overview of metabolism? What's the overview of metabolism?
What's the overview of metabolism? I am the book, b****. I told you not to touch me. I made it clear to you.
Sorry.
Well, according to me, the book, just as gasoline is the fuel that powers automobiles, so too, food is the fuel that is metabolized by the body to provide energy. Metabolism breaks down the carbohydrates, proteins, and lipids in food into smaller molecules, releasing energy to supply the body's needs. This process involves numerous catabolic pathways that can be organized into 4 stages.
But excuse me, sir. What are those 4 stages you're telling me about?
Is this thing on? Fine, ano? Yan. Digestion. This is the first step of catabolism. In here, large molecules are converted into smaller ones. Now, carbohydrate digestion begins with salivary amylase in the saliva, and it converts them into monosaccharides, and it is transported through the small intestines. Now, protein digestion begins in the stomach, wherein acid, it denatures the protein, and then the protease pepsine cleaves the protein backbone into smaller polypeptides and amino acids. Now, once these small molecules are formed, they are then transported and absorbed into the intestinal walls, into the bloodstream, and into the whole body. The second stage of catabolism is the formation of acetyl coenzyme A. Now in here, monosaccharides, fatty acids, and amino acids are degraded into acetyl groups. Here. After that, it is bonded to the coenzyme A, which produces this. And this is the coenzyme A, and this is the acetyl group. Now, the product of all these catabolic pathways is the same. As a result, a common chain called the citric acid cycle continues the processing of all these biomolecules. Oh, wait. Smart C, bottoms up. And it has citric acid. Oh, speaking of citric acid, the third stage in catabolism is called the citric acid cycle. Its basis is in the mitochondria. Now, in here, the acetyl groups formed by the acetyl-CoA enzyme A is then oxidized into carbon dioxide. Some of the energy produced in the process is stored in the bonds of what we call A, the placid triphosphate. The last stage of catabolism is the electron transport chain and oxidative phosphorylation. Now we said a while ago that in citric acid cycles, the acetyl groups are oxidized and reduced. The reduced molecules of this are transported to the electron transport chain. Now in here, electrons are transferred from one molecule to another through oxidation and reduction reactions. Now it will keep on happening until an electron and a proton bonds with water. Here. And after that, as energy is being released, there is a tendency for it to cross an inter-mitochondrial cell membrane, which produces an energy reservoir, and it is used to produce ATP through oxidative phosphorylation.
Hey, you with that shirt? Come on, girl. I want to talk to you. What's up? So I just have one question. How does ATP use in energy production?
Hydrolysis of ATP cleaves one phosphate group, forming ADP and hydrogen phosphate. This reaction releases 7.3 kcal per mole of energy. Get it?
So, can I get your number?
Check it out.
Babe, why do compounds such as cyanide act as poison when they disrupt the electron transport chain?
What's that on that beat? Oh.
Magnanakaw! Natatayo ko lang dyan! Takbaw!
Since all catabolic pathways converge at the electron transport chain, these steps are needed to produce energy for. Normal processes, compounds that disrupt a single step can halt ATP synthesis so that an organism cannot survive.
Ay, sakit mo. Cyanide from HCN irreversibly binds to the iron 3 plus ion of the enzyme cytochrome oxidase, and as a result, iron 3 plus can't be reduced to iron 2 plus, and water cannot be formed from oxygen. Since the electron transport chain is disrupted, energy is not generated for oxidative phosphorylation, ATP, is not synthesized, and cell death often follows.
Hey babe! Hey! Uy, pansinin mo ako! know.
What is the purpose of mitochondria?
Energy is produced in the mitochondria, an organelle that contains an inner and outer cell membrane. Energy is produced in the matrix, the area surrounded by the inner membrane. Get it? Oh my! Papi! Dito, problema mo. Don't you want me?